Hello again. In this video we're going to look at tuples. Tuples in C++ are related to pairs, so let's first remind ourselves what those do. A pair is a compound type. It has two members which we can access with the names first and second. These members can have any type. We can create a pair object explicitly by giving the types of the elements as template parameters. So here we have a pair which has two members of type string, or we can use makePair to create the pair object with auto. So in this case the compiler will deduce that wordPair is a pair whose members are both type string. In C++11 we have a tuple type in the library. It's defined in the tuple header. It's similar to the pair, but it can have any number of elements. The number of elements has to be fixed for a particular object. It's not really practical to use the names of members, so instead we use the index for accessing the elements. Again, we can create a tuple object explicitly by giving the types of the members as template parameters, or we can use makeTuple and let the compiler deduce it for us. The way that we access tuple members is a bit peculiar. There's a non-member function called get. This takes the tuple as argument, and then it has a template parameter which is the index of the element. So if we call get with parameter 0, that'll be the first element, and then we pass the numbers tuple. So this will return the first element of the numbers tuple. And we can also assign to the return value from get. So we can actually use get to set the value of an element, which is perhaps rather confusing naming. But that's quite common in C++, I'm afraid. So in this case we're getting the second element of numbers and setting its value to 3. In C++14 we can also use the type of the parameter, provided there's only one element which has that type. So we can call get with parameter int, and that'll return the member of numbers which has type int. So let's try this out. We create our tuple. We pass the types of the elements as template parameters. Or we could also call makeTuple. There's our call to get with parameter 0. So this is going to return the first element of this tuple. Get with parameter 1 will be the second member of this tuple, and then we can set that to 3. If we have the parameter type of int, then this will return the member which has type int, which is this one. We just set that to 3, so we would expect that this call will return 3. And there we are. First element is 1, second element set to 3. It's also possible to get all the elements of a tuple with a single call. There's a non-member function called tie which does that. And again, this is a bit peculiar. We need to have some variables which we're going to use to store the data. Then we pass those variables as arguments to tie, and then we assign the result of calling tie. So this is going to extract all the elements from numbers and then store the first element in D, the second element in I, and the third element in str. And obviously the number and type of these variables must match the elements of the tuple. So let's try that out. We have the same tuple again. We have the variables which we're going to populate. Then we call tie, we pass the variables, and then we assign this to the numbers tuple. And then we print out the result. So there we are. The tuple elements are 1, 2, and 3. So when would you want to use a tuple? One good example is if you have some data and you just want to stash it somewhere without too much trouble. If you don't want to write a class and think about member functions, special member functions and so on, and you're not actually going to use that type anywhere else. And this is especially useful if the data has elements of different types. Otherwise you could use a vector or an array or some other container. Another good example is returning multiple values from a function call. This is a question I've been asked at interviews. If you have exactly 2 values, you could use a pair, but in the general case you have to create a struct think up a unique name for it in that namespace, then think of names for all the members, then populate all the members in the function body, and then in the caller you have to copy all the data from the members of the struct into your own variables, which is all a bit tedious. With a tuple you can do it much more conveniently. You can have a function which returns a tuple, so you just make the parameters the right type for your data. You can use a list initializer for creating this tuple object, so you can do that with variables as well as literals. And then in the caller you just call tie, and then this will copy the data from the returned tuple into your variables. Unfortunately, we cannot use auto, at least not in C++14, because tie is not able to deduce the types of the elements. It's just too difficult. So here is that code. Here is our function which returns a tuple. Then we create this tuple using the list initializer. Then we have the code which unpacks the tuple into these variables, and we unpack the tuple which was returned by the function. So this should give us the data from the function. And there we are. Okay, so that's it for this video. I'll see you next time, but until then, keep coding.